we're talking about introduction of the topic. So the first one is concrete containing cement, water, aggregate, and discontinuous, uniformly dispersed or discrete fibers is called fiber-reinforced concrete. 2. It is a composite obtained by adding a single type or a blend of fibers to the conventional concrete mix. 3. Fibers can be in form of steel fibers, glass fibers, natural fibers, and synthetic fibers. Continuous meshes, woven fabrics, and long wires are not considered to be discrete fiber because of some workability and impact-resistant demerits.
Hi everyone. Now I will explain about objective of fiber reinforced concrete. First is knowing the definition of fiber reinforced concrete in building industry. This part will be collaborating by Sarah. Second is improving the durability and toughness performance of fiber reinforced concrete in building industry. Thirdly, we explore the type of fiber reinforced concrete that used for building industry. This part will be presenting by Haizan. Next, studying of advantages fiber reinforced concrete in building industry, which will be explained by me later. Last but not least is studying the advantages of fiber reinforced concrete in building industry that will be collaborated by my friends. That's all from my season. Now I will pass it to Sarah.
Alright, now I'm going to talk about the introduction of definition of fiber reinforced concrete. Fiber reinforced concrete, or known as FRC, is a type of concrete mix containing fibrous materials to improve its structural integrity. Primary effects of fibers in concrete include reduction in cracking and increased load carrying capacity. It contains short, discrete fibers that are uniformly distributed and randomly oriented. Also, types of fibers include steel fibers, natural fibers, synthetic fibers, and glass fibers. The properties can be altered by changing certain aspects, including the geometry, configuration, direction, dispersal, concentration patterns, type, and quantity of fibers.
Hi, I'm going to tell you about the type of fiber reinforced concrete. There are 6 types of fiber reinforced concrete. Number 1, steel fiber reinforced concrete (FRC). Number 2, polypropylene fiber reinforced concrete (PFR), cement mortar and concrete. Number 3, glass fiber reinforced concrete (GRFC). Number 4, asbestos fibers. Number 5, carbon fibers. And the last one, number 6, organic fibers. Now I'm going to tell you about the type of FRC, and I'm going to explain it. All six of FRC. Number 1, steel fiber reinforced concrete. No steel fiber types are available as reinforcements. Round steel fiber, the commonly used type, are produced by cutting round wire into short length. The typical diameter lies in the range of 0.25 to 0.75 mm. Steel fibers having a rectangular CS are produced by sheeting the sheets about 0.25 mm thick. Fiber made from Mars steel drawn wire conforming to IS 2X01976 with diameter of wire varying from 0.3 to 0.5 mm have been practically used in India. Number 2, PFR cement mortar and concrete. Polypropylene is one of the most cost-effective and widely available polymers used in construction today. These fibers are highly resistant to most chemicals, ensuring that the cementitious Metric itself would likely deteriorate under aggressive chemical attack long before the fibers are affected. Furthermore, its high melting point of approximately 165 Celsius allows for a reliable and stable working temperature in various environmental conditions. Number 3. Glass fiber reinforced concrete. Glass fiber consists of 200 to 400 individual filaments that are lightly bonded to form a single strand. These strands can be chopped into various lengths or woven to create cloth mats and tape. When using conventional mixing techniques for standard concrete, it is difficult to incorporate more than approximately 2% by volume of 25 mm fibers. The primary application for glass fiber is reinforcing cement or mortar matrices, specifically for the production of durable thin sheet products. Number 4. Asbestos fibers. Asbestos is a naturally occurring, inexpensive mineral fiber that has been successfully combined with Portland cement paste to form a widely used product known as asbestos cement. These fibers provide excellent thermal, mechanical, and chemical resistance, making them highly suitable for manufacturing sheet products, pipes, tiles, and corrugated roofing elements. Number 5. Carbon fibers. Carbon fibers are among the most recent and likely the most spectacular additions to the range of fibers available for commercial use. These fibers possess an exceptionally high modulus of elasticity and flexural strength, though they are quite expensive. Their overall strength and stiffness characteristics have been found to be superior even to those of steel, making them ideal for specialized structural reinforcement. And the last one, number 6, organic fibers. Organic fibers such as polypropylene or various natural fibers can be chemically more inert than either steel or glass fibers. They have also highly cost-effective, especially when sourced naturally. Incorporating a high volume of vegetable fiber can be used to create a multiple cracking composite, which enhance durability. Any challenge regarding the mixing and dispersion of these fibers in the concrete can typically be resolved by adding a superplasticizer to the mix. That's all.
Now, I will talk about benefit of fiber reinforced concrete. There are 6 benefits of fiber reinforced concrete. First one is it has high durability and does not cause corrosion not like regular concrete. The second one is it significantly reduces labor cost compared to steel mesh. And the third one is it increases the toughness and energy absorption capacity of concrete. Next, it has high chemical and alkali resistance. Second last is it increases the bearing capacity of concrete and provide effective crack control. And the last but not least is fiber reinforced concrete improve resistance against freezing and thawing.
So I will talking about application of fiber reinforced concrete. The practical use of fiber reinforced concrete hinges on the ability of builders and applicators to leverage the material's inherent static and dynamic properties. For the tunnel construction, FRC creates ductile durable linings that resist cracking and spalling and extending service life. Fibers are added to shotcrete for ground support, offering superior crack control and energy absorption in a stable ground. So for the traffic areas, enhanced toughness and impact resistant FRC better withstand repeated heavy wheel loads and sudden impacts, common in high traffic areas. Reduce spelling. The fibers help hold the concrete matrix together, lessening the breakdown of edge at joints and cracks. And the last one, residential construction. Synthetic or natural fibers help manage cracks, improving performance and aesthetics. Fiber provide internal reinforcement, controlling crack and improving the cracking strength for the longer life, and maintains the design of architecture.
Although fiber reinforcement concrete offers many advantages, it also presents certain disadvantages. The first one is it must be mixed carefully. The fiber reinforced concrete must be carefully mixed and evenly dispersed throughout the concrete. It's because improper mixing can lead to a high margin of error, causing fibers to bunch up, which affects uniform dispersion even if monitored carefully. The second one is the cost. Compared to non-fiber concrete, fiber reinforced concrete is more expensive. However, it should be noted that most concrete is reinforced in some way and many projects require it. The third one was the weight. The weight difference between fiber reinforced and non-fiber concrete is another drawback to be mindful of. Adding fiber to concrete generally increases its weight, which adds to the average structural load.
So, for the conclusion, fiber reinforced concrete exchanges traditional concrete by adding small steel, glass, or synthetic fibers to each mix. While standard concrete is strong under compression, it is naturally brittle and prone to cracking when bent. The added fibers create an internal network that significantly improves toughness and resistance to impacts, vibration, and extreme weather. The primary benefit of FRC is the bridging effect. The fiber act like internal stitch that hold cracks together, preventing them from spreading and causing structural failure. This makes the material safer and more durable than traditional concrete, reducing the need for steel mesh in high stress environments like tunnels, bridges, and industrial floors.